Okay, so number 23 on page 716. And we did our geometry unit with 7th grade. And look at my diagram. Does it look like it's accurate with the length measurements? Like 15 here, that's 3. Maybe not. Doesn't matter. No. I'm just trying to draw a picture. If you draw it more exact, it might look more like something like that. Maybe. But the whole point is that this picture does not determine my answer. It's the numbers that I give to it. So you'll be prepared for that in geometry. Sometimes it'll look like this, and you'll be like, oh, I can almost measure it and figure it out on my own. Sometimes it'll be like that, and you'll get your answer and be like, what? How is that even possible? And it is, because of the numbers. Don't worry about the pictures so much. Okay, so it's B. Taylor? 200. Sorry, 200 what? I didn't hear. 216? Okay, so on this one, I'll just work with this one. Yeah, 15 squared equals 3 squared plus b squared. So what's 15 squared? 225, 9 plus b squared. Subtract 9 from both sides. You get 216 equals b squared, square rooted. So that's your b. And I'll let that go for your Pythagorean theorem. So is that a perfect square? No, so you leave it alone, you got it, you're done. Because in our next lesson, you have to make this simple, if possible. But Pythagorean theorem, you're okay. All right, that's Pythagorean theorem. That's lesson -1. Mm-hmm.
So question about that, since you'll let it go, you said that the test was kind of jumbled around. So
I said it could be. I'm actually probably not going to do that.
Because... Okay, you're probably
if it's
right.
Pythagorean theorem, you can leave it alone. And another thing is the A, B, C, D choices. You'll have this and then 2 other ones. If you look at your work, then you'll be able to say that's it, right? Because you did it, you got that answer, so you know that has to be it compared to the other choices. Yep. Okay. Let's start with page 724. And this lesson has a lot of types of problems, kind of like number 11. So if you're doing number 11 on page 724, yes, number 11 is always a good one. The square root of 3/7. That answer is not simplified, and somebody needs to tell me why. Why is that not simplified? Because it looks pretty simple to me, but there's one thing I do not like. And it makes it very hard, and it's really irrational. Okay? The denominator is an irrational number. So I need to remember I can write this like that. Am I allowed to have a radical in the denominator? No. So I multiply that fraction by, which is a form of 1. Good. So square root of 7 over square root of 7. And the square root of 3 times the square root of 7 is the square root of 21. The square root of 7 times the square root of 7 is either the square root of 49 or 7. Which one's more simple, the square root of 7 or the square root of 49? 7. And can I factor this anymore? No. Do I have a radical in the denominator? No. Can I cancel anything out? Numerator, nothing. I'm done. Square root of 21 over 7. That's it. Okay, another type of problem will be like number 7. So I want that to be simplified. So is this as simple as it can be? No, because the denominator is a irrational number. I can't have that. So I'm going to multiply by, oh, look at that. Same thing I did the first time. By 1 in the form of this. 4 times the square root of 7. 4 times the square root of 7. The square root of 7 over the square root of 7, or times the square root of 7. And then can I cancel these out? Nope. Can I cancel those out? Can I simplify this? I'm all done. Okay. Then you get problems, and I want to start throwing some things at you a little bit more difficult. Number 12. Number 12. You have two radicals being multiplied, and let's see if you guys can handle this one. First, the quotient square root theorem is saying you can write this first fraction like this, and I can write the second one like this, and then I can multiply. But if you remember anything from previous chapters, you can cancel out common factors. Are these being multiplied together? These are being multiplied together. So we have common factors. You can go ahead and just get rid of that. I'm left with the square root of 5 over the square root of 3. And that is not my answer because I have what in the denominator? A radical. It's irrational. So then I'm going to multiply by a form of 1. And that's going to get me the square root of 15 over 3. And that's as far as it goes. Yes, sir. Okay. Okay, I'm going to step it up even more here. Number 13. So like I said, this lesson has a lot of different types, but same principles are at work. And it is review of other material, which is very nice. What process are we going to use here? FOIL, which is a way of using the distributive property. So that's what we're using, FOIL. So first, what's the square root of 2 times the square root of 2? What do those multiply to get? 2. Or the square root of 4, which would be 2. Good, good. What's the square root of 2 times 6? 6 times the square root of 2. Then I'm going to do inner, so what's 4 times the square root of 2? It's just 4 times the square root of 2, just like you say it. What's 4 times 6? Positive 24, okay? You got your 4 terms, and you notice you have what kind of terms? Like terms. So you can combine like terms together, and here you're going to get 26 plus, what happens when I add these two together? 10 times the square root of?
2.
Oh, I heard it.
2. No.
Oh, I heard it again.
It's 2.
Okay.
Adding.
Oh my, Kyra, what?
Good job, Kyra.
You're trying to trick us.
Not me.
Yes.
Okay, when do you change the roots within a radical? When you're multiplying them. When you're adding them, you keep them the same. So here, didn't we change? Well, technically, didn't we do the square root of 2 times the square root of 2, which would be the square root of 4, and then we reduce that. But here we're adding. Don't change it. Good. All right, next lesson. Page 730. 730. We'll go through, I think, one problem here that's pretty representative. Number 32. Number 32 on the next lesson, page 730. Yes. So here what you're trying to do is you want to combine like terms, but it's not always clear. So I want to simplify all of them so I can find those like terms maybe more easily. And factoring is a nice way of doing it. Okay, check that. Make sure I'm good.
Yep, looks good.
Thank you.
No problems.
Okay, now this is a review of this concept. I can simplify this because I have a pair of 2's. How do they come out as?
Fours. Well, like, I'm a step ahead. Okay.
That's okay. They come out as the square root of 4, which is really 2. So they come out as a 2. What do they do with this 2 that's already there? Make it a 4. Leave whatever in the square root that didn't get taken out where it belongs. Minus, I have another pair of 2's. It comes out as 1, 2. And I get negative 6 times the square root of 6. Here I have a pair of 2's and a pair of 3's. I get a 2 to come out and a 3 to come out, which makes it negative 6. Negative 6 times the square root of 5. Now that I have it simplified, I can see clearly, oh, these are like terms. 4 times the square root of 5 minus 6 times the square root of 5. Negative 2 times the square root of 5 minus 6 times the square root of 6. Sorry, I ran into my work. There we go. Okay. Almost there. We're getting there. Page 735. Actually, 734, just the page right before it. 734. Now you're solving equations. So you need to make sure you find what A is, and I'm going to ask you if you're really correct or not. Number 8. Number 8 on page 734. 8. On these problems, you want to make sure you do what first? You guys remember what my goal was? Before that, I want to isolate this radical all by itself. Get it all by itself. What undoes this square rooting? Squaring. If I square that side, I got to square the other side. 13 squared is 169, and then I got rid of that. I got 2y minus 5. Then I solve for y. So I'm going to add 5. I get my 174 equals 2y. Divide by 2. I get my 87 equals y. Is that my answer?
Oh, no.
Check.
Oh. Didn't it open up for improbable solution?
When you squared, no.
Oh, wait, never mind.
When you square
That's
root
square
both
root,
sides,
yeah.
plus or minus. So when I squared both sides, you just drop signs or find that out. But if you square root both sides, you get a plus or minus. Okay, is that my answer? Let's check. So here I'll do this. Do my check. Okay, what's 2 times 87? 174 minus 5? 169 square rooted? That has to be it. That checks. That was too easy. You guys got it too quickly. How many of you got that one, by the way?
Number 11.
Do number 9.
Any other requests? How about number... Oh, I don't know. That one's tough. 32.
Ooh.
On page 735. Number 32.
Oh.
Different numbers, same process. Trust the process. Sorry? Trust the process. That's my favorite saying ever. Almost. Okay, is the radical by itself?
Yes.
So we can do what now? Square. But if I square both sides, I better square both sides. I got to square both sides. 1 minus 2m equals, I got to square this. So it's basically like doing FOIL. Because 1 plus m squared is 1 plus m times 1 plus m. Which is 1 plus 2m plus m squared. And do your FOIL to figure that out if you needed that. Do FOIL. Check it. I don't know if it's right. Okay, once you get it all worked out, you can add terms on both sides, if they're like. We're good with that. And then when you have a square term, this is a general rule for equations. If you have a square term, your best bet is to get everything on one side or the other and get what on the opposite side? 0. So I'm going to subtract 1 from both sides and add 2m to both sides. I'll get this to cancel and that to cancel. I get 0 equals, that cancels out, m squared plus 4m. That is very familiar. Then I can factor that out by getting my GCF, and then I have my answer.
Your answer is multiple 0
Trust the process. I haven't circled anything yet.
Do it.
No.
Do it.
No. Not circling.
It's yours.
Okay, let's see here.
They turned green.
Oh, they did.
Oh, they turned green.
Whoa.
Damn it. Okay, let's try 0. Can we try that out? What's negative 2 times 0?
0.
All right, 1 plus 0.
0.
1 plus 0 is 1.
Oh,
So you get the
sorry.
square root of 1 equals, what's 1 plus 0? Is that good?
Yes.
Okay, 0 works. 0 is an answer. Let's go with 2 times negative 4. Or sorry, negative 2 times negative 4. Positive 8 plus 1.
9.
Square root of 9. What's 1 plus negative 4? Negative 3.
Oh, so it technically does work.
It does and doesn't.
Couldn't it be 3 and negative?
Okay, I want you to do this, please. You need to talk to your neighbor or someone around you, and you're going to come up in 30 seconds with the answer. Is this an answer? We know this is.
I think it's tough.
It is an answer because
This is our last math lesson.
but
Our last math lesson. Sorry.
Say that again?
This is our last math.
No, we have 2 more.
So you have to square root, right?
specific part
Distance formula and completing the square.
Wait,
Okay. Sorry? No, like to review. Okay, negative 4. When I put it in, I get this. Is this true? There's a technical answer and there's a correct answer.
Apparently,
Okay, how many of you would circle negative 4? That's what I'm, I guess, asking for. How many of you would not circle negative 4? Not circle negative 4? The correct answer to that question is I do not circle negative 4.
I'm confused.
Okay, I'm going to tell you this right now. I'm not going to give you one where you're going to have to split it like that because that's hard. But when I ask for the square root of 9, I only want the positive version of that. Okay? If I wanted the negative version, negative 3, I would have done that.
Oh.
Or I would have said, yeah, plus or minus, I want both of them. But I didn't do that. So if you didn't get that before today, that's okay. But I want to go through that because that's the case. So sorry, that's not true. Wait, that's not what I wanted. Okay, let's keep going. Next lesson. Second to last one. 739. Page 739. Hurry, go, now. All right, who knows the distance formula? Hayes.
Square root x sub 1 or substitute minus x sub 1 squared plus y sub 2 minus y sub 1 squared.
No, he said the y sub negative y sub 1 squared.
Okay, I thankfully we interpret that message like this, but with that understanding, could I have moved this whole part right here and switched it with this part? Can I flip-flop? Because of what property? Commutative. Could I switch these two, this one and this one, and this one and this one? So I can switch that? I can switch that? Yes, I'm finding the difference, which is actually commutative property as well. And squaring something will always make it positive. Okay, so go ahead and do number 14 on page 739. Number 14, please.
Unless you square root an imaginary number.
If you square root them, it's the whole thing. But if I square
I
them,
mean, if they square.
Actually, an imaginary number squared is a real number.
Wait.
I like. Walker, stay with me here. I want to give you something. You're ready for it. The square root of -1 is imaginary. I can't graph that on a number line. And we're going to represent the square root of -1 as the letter I. So when I see this, I can think I. Or when you see this, I think of square root of -1. But what happens if I square I? Isn't that saying the square root of -1 times square root of -1? Okay, now, the square root of -1, I don't know it. The square root of -1, I still don't know it. But when I multiply them together, if you follow the pattern, it's actually worth -1.
Wait.
Do you remember when you do this, you get whatever's inside. So you got to get -1.
So can I also equal
Whoa. Oh yeah, you're right.
No,
You're right.
no, this is a value.
Wait,
I
squaring it does make it a negative number. So that's when squaring it does make a negative number.
Yes, you can think of that when you're dealing with imaginary numbers.
Yeah.
Complex numbers, which basically deal with this I. I is the key to imaginary numbers. E is the natural logarithm, which is a number that we found to relate to all numbers in a special way. Oh my goodness, that's logarithms, that's algebra 2. You'll definitely get that.
So like you can't use E as a variable because that's
Actually, when I think of that, you can use a number, if you know what it is, you could still use that as a variable. Because variables are actually numbers, so you can interchange them. But okay, what'd you guys get for this? The square root of 8?
90. I'm probably
Oh my. Okay. I get something else, and somebody tell me why I got this.
because you're a genius.
No.
That's what I put.
Yeah, I did that.
Did you guys get the square root of 80?
Yes.
Okay, but that can simplify into this.
I have a question.
And I guess it was, you just get
Okay.
you just get the prime factorization and then.
Oh, yeah. Prime factorization of 80. You take out 2 pairs of 2. Then you got your 4 times square root of 5. Yep.
So like with rocket scientists, they have like a really
There is a degree for rocket science. Go ahead.
There's like a really long number. And they use a variable to put in an opposite. Do they have to use a key or something?
I see.
Maybe, but either they know the number because it's super special and super known and super useful, or you can use a key. Or like you would come in and say, "What's that?" Here's the key. Oh, you could do that. Oops. Okay, page 746, last problem before I give you the homework. Yes. 746. Yeah, 746.
Wait, so we told to come to class.
Oh, homework. Yes, you have class today, or Monday, or Saturday. I mean, whatever day you want to take it. I'll be here. Number 18 on page 746. Number 18, just complete that square. Find out what number goes in for C. Oh. Okay.
No.
Okay. What do you do here? How do you find out that's C? First, Benson? You put negative 18 divided by 2, which equals negative 9. So 81. That's always positive.
Wait, so what, 81 times 9?
What? Why 81 times 9?
Oh,
Because
81 times 9?
9.
Oh.
You can do your bridge method and factor that out. You get this part that I'm not asking. All right, please listen.
Mr. Technically, since class already finished, you can't assign homework. Is that right?
So I can't give you bonus.
That's true. Okay, we'll take it.
All right, please listen. There aren't many, but there are good practice problems. All right. Number 2, 5, 7, 12, 15, 16, 20, and a pretty tough one. Try it out. If you try it, you get your bonus, number 23. I'll say it one more time. And then I'll tell you the page. Hold on. 2, 5, 7, 12, 15, 16, 20, 23, page 799. Page 799. If you just do that those problems, you'll get your bonus point.
So, Mr. Ray, do we have graduation practice?
Sorry?
Yeah.
All right. Head on to the sanctuary.
Takes class.
Do we take our
Sorry?